What's up? This is SAT Practice Test 8 from the Bluebook. The whole math section is supposed to take 70 minutes. I'm going to do it in about half that time, get a perfect 800, and walk you through every Desmos shortcut I use along the way. By the way, I built a tool to help students practice exactly this kind of thing, and I'll show you that in the middle. Let's go. Number one here, open up Desmos. Let's make it a little bigger. Pretty simple question. What's the y-intercept? Where does it cross the y-axis? At 8. That should be pretty simple. Number two, a function question. These are also pretty simple. You could probably evaluate that mentally, but also remember with Desmos, we just type this in, right? They're telling us x is -8. Throw that in there. We get 84. No mistakes. Next one is just a reading one. Producers creating a video with a length of 70 minutes. A video will consist of 1 minute long segments and 3 minute long segments. Which equation represents this, where x is the number of 1 minute and y is the number of 3 minutes? That's really all you got to get right. X with 1, 3 with y, and that's basically it. So x plus 3y is 70. Next one, a bowl contains 20 ounces of water. When the bowl is uncovered, the amount of water decreases 1 ounce every 4 days. If 9 ounces remain, how many days was it uncovered? One thing sometimes people get wrong with this, they don't use all the information, right? One way the SAT doesn't try and mess with you is they don't give you information you don't need. So you got to figure out how all this information works together. So you add 20, you're left with 9. That means you used 11, and it's 1 ounce every 4 days. So that's going to be 11 times 4, that's 44. Next one here. Each of the dot plots represents the number of glue sticks brought in by each student for 2 classes. Class A and B. Which statement best compares the standard deviations? So just looking at this, I know the standard deviations are the same. What you want to know about standard deviation, let me pull that up. Where do we got standard deviation? We have that somewhere here. There it is, up in the corner. Here's an example. Just think about standard deviation as spread. If you just like literally remember this word, you'll probably like figure out most of them just by looking at them. So if they have different spreads, they're gonna have different standard deviations. Here, their dot distributions are identical, right? So that's one reason they would have same standard deviation. But one reason they would possibly still have different standard deviations is if these numbers were incremented by different amounts. These numbers always go up by 1. These numbers always go up by 1, so they'll be equal, right? But you can also check this in Desmos, right? If you type STDEV, you can type in like a couple of these. I won't type in all of them. You see, like I'll type in the first 3 numbers of each, 1, 2, 3, 3, 3, and then over here 14, 15, 16, 16, 16, right? And you see identical. If you entered in all of them, you'd still see it's exactly the same, right? But yeah, just by looking at that, you should be able to tell for most of them. Just keep that idea of spread in mind. This one here, there's a way to do equivalent ones in Desmos. If you watched the previous videos, you probably saw it. You can just put this in Desmos and see which one of these is the same, but honestly, pretty basic. Just, do your math. Just make sure you distribute the negative to both of them. That's the trap answer here, right? So it's 7x cubed minus 6x cubed, so that's x cubed, and then 7x, and it'll become plus 3x, so 10x, right? But let me show you that real quick in Desmos as well for those that may not have seen the previous video, right? This will be useful in other situations where we have more complicated ones, right? So if I type this in like this, there's my graph, right? And now you'll see if I type in A, they're identical, right? And that's how you know they're basically the same as well. Just you can match them up with a graph. Next one, triangle ABC. A is 54, B is 90, and C is K over 2. What is K? So geometry is a part of the test where you will kind of use your scrap paper. We don't need it really for this problem, but that's what the scrap paper exists for, right? You can sketch it out. I find that useful for a lot of geometry problems, but this one's pretty basic. A triangle, we know, adds up to 180 degrees, right? And then they give us 2 of the angles, right? So just take those away, 180 minus 90 minus 54. So it's 36. 36 has to equal K over 2, right? So you just multiply by 2 and we get 72 for K. That's it. Next one, solutions. This is a key word you got to remember, right? If you have solutions, just type that into Desmos. It always just shows you the solutions, right? So here it is. We see 3 solutions. Usually you can click on them. Sometimes it doesn't let you click on it. So you got to like zoom in and see that, oh, this is -5, then 0, and then 4. So those vertical lines are your solutions. The one that shows up there, 0. Next one, chemist combines water and acetic acid to make a mixture of 56 milliliters. So that's these two combined together is 56. They tell us the volume of acetic acid is 10. What is the volume of water? This is a funny one. Sometimes they sound worse than they are. You literally are just subtracting two numbers here, right? They gave you the total. They gave you what this one is. They want to know the water. That's just 46. Next one, conversion problem. We have a distance of 354 furlongs, right? And they want to know how much feet, right? They'll usually give you all the conversions you need, except like really basic ones like time. They won't give you like minutes to seconds, things like that. But conversions, where's our conversions, unit conversions? Over here. Here's an example, right? Basically, if you've done chemistry, you should be comfortable with this. This is just dimensional analysis, right? Just write it so your units line up. Like here, if I want to go from feet per minute to yards per hour, right? We got this conversion of feet to yards. They'll give you that as well. See this first one here, I line it up this way just so my units of feet cancel out, right? So that's basically all we have to do here. So if you add this, it'd be like this. I write it 354 furlongs over 1, just because it's not a fraction here. And then I'm going to multiply it, right? What am I going to multiply it? First, use this conversion factor of furlongs. So since furlongs on the top here, now furlongs is going to go on the bottom here, 220 yards on top. And then now we're in yards. So now we have to change it from yards to feet, right? So I can go ahead and do 3 feet on top, 1 yard on the bottom. You see, now I can make sure everything just kind of cancels out nicely. And then for the math, just write it without the units, right? So the units I just write just to make sure I've lined up everything correctly, but there it is, that big number, that's it. Next one here, at how many points do these intersect in the XY plane? Well, you might just be able to look at this and be like, these are parallel lines, so it's going to be 0, but you can just kind of confirm this, right? This is like one you don't want to get wrong. It's pretty basic. Just you can type it in Desmos and literally see, you know, do they intersect each other or not? And no, you'll see that they're parallel lines, right? I know that because they're lines and they have the same slope. Next one, percent problem. You want to be able to translate some of these percent problems. Like this is literally an equation, right? You can write it. 13 is just 13. Is your keyword for equals, right? P percent, I can write P over 100 to represent something as a percent of is a keyword for multiplying, right? And 25. And that's my equation. And Desmos will solve this for me. It's just, I need to make the unknown X for Desmos to solve it. And you see, I can zoom out and just click on my answer and it's 52. Next one. This function, it's an exponential function, right? One thing you want to be able to notice on the test or recognize is what kind of equation you have. The SAT is pretty nice because there's really only 3 fundamental equations that most problems will be. You'll have a linear equation. We saw that with the lines I just talked about. I knew they were lines. I knew they were parallel. I knew it was 0. Here it is an exponential equation. And then you also have quadratic equations, right? These are like fundamental things on every test. Here's your exponential equation, right? What you want to know is this first number here. That's your initial value. That's the y-intercept, right? And this in here kind of tells us about the rate of increase or decrease, right? And the exponent. So here you know you have an initial amount of 60,000 bacteria, right? And the question is, how much time will it take for it to double, right? Well, that's the whole point of this 2 here, right? The 2 is the doubling, right? Sometimes we'll say triple, it'll be a 3 there. You could say it halves, that'll be a 1/2 in there, right? That's going to be like our increase or decrease, right? If you think about this, this is a pretty simple problem, right? We have 60,000 to start. If you wanted to double it, you would literally just do 60,000 times 2, right? Now, what does that imply about the exponent? If you just want it to be 60,000 times 2, your exponent has to be 1, right? I've seen this question so many times, and it's a really simple one if you understand this idea and understand the exponential equation. You want the exponent to be 1. So what value of t is going to make this 1? Well, it's t over 410. So t has to be 410. That's one usually people don't get right the first time, but honestly, it's a pretty simple problem if you've seen it before. Next one. This one's also actually related to exponential equations, right? So we kind of had it over here. Usually we represent exponential equations in terms of percent increase or decrease. The last one said doubles. Doubles is just an increase of 100%. They'll just never say it that way, right? So you just kind of want to know things that double, triple, anything like that. That's also exponential. But yeah, this literally says increases by 0.49%, right? That's exponential, right? And it's increasing, so it's increasing exponential. Next one, circle in the XY plane has a diameter with endpoints 2, 4, 2, 14. An equation is given and they want to know what is r, right? So this is the circle equation. You want to kind of know your circles, right? One thing is the circle equation. It's already kind of in this form, right? So what we kind of have to do with this one is a little interesting. They're telling you these are the endpoints, right? So if you took the distance between these, right, this one way to do it, if I plot this, you'll kind of see it. If I plot these 2 points, right, here they are, just zoom in a bit. These would be the endpoints. The endpoints, the distance between the endpoints is your diameter. So this is a diameter of 10 units. So the radius is 5, right? And that's what r represents. It's 5, right? But here's another way. Here's a cool thing you also want to know, right? Because it could be useful in other problems. If they give you points, what you want to remember with a point is literally just an x and a y, right? So even if you didn't kind of make that connection that I showed you, literally just plug in either of these points for x and y. I'll show you that right here, right? So if I plug in 2 minus 2 squared, right, plus 4 minus 9 squared, right, this is going to equal r squared, right? So what was this value? It was 25. So we have this 25 equals r squared, right? So r is obviously 5, right? So that's another way you could do that. Here, we got a triangle, right? So this is probably one you kind of want to sketch, right? When they tell you you have a right triangle, we saw one earlier, they usually tell you which angle is the right angle. That's the only thing that really matters. If you draw a right triangle and you get the wrong angle as the right angle, you're just going to mess up the problem, right? So you want to kind of sketch these out. So let me sketch this out. R is t, and it says the sum of r and s is 90. So this is important. The sum of r and s is 90. Neither of those are the 90, right? They're the acute angles, right? So t is the right angle. So let me go ahead and go over here and kind of sketch out a right triangle really quick, right? So there we go. All right, so this is why you still want to use kind of like your scrap paper. And here's our right triangle. And what we said was, we said t over here, right, was the right angle. And then we could put r and s. It doesn't matter where those are, right? So what else do we kind of have here? It said that the value of sine of r is square root 15 over 4, right? Obviously, then you still have to know your trigonometry, basic SOHCAHTOA. That's what you'll see. So if it's sine, then this is the opposite. This is the hypotenuse, right? So we can fill that in over here in our picture, right? So that was from r's perspective. So opposite of r, so that would be over here based on how I drew it. This is square root 15. And then the hypotenuse over here, this is 4. You got to do Pythagorean theorem, right? That usually kind of is one of the things that just goes together with these right triangle problems, right? SOHCAHTOA and Pythagorean theorem, you usually use it to find like the missing one. So you can do that in Desmos actually, right? So we can just do a squared plus b squared equals c squared into kind of Desmos and find that missing one. You could probably do that mentally as well, but here I'll kind of show you in Desmos. So if I write this into Desmos like this, I could just write this and you see it'll figure out what that, sorry, I messed this up. This is square root 15 was the leg, sorry. And then plus x squared equals 4 squared, right? There we go. And then you see I can just kind of click on, my answer and it's just 1. The missing side is just 1. So go back to my picture here. I can kind of fill in 1 over here. And what's the final question? The final question was cosine of s, right? So cosine of s, I actually didn't really even need that. You see if I just kind of looked at it beforehand. From s's perspective, square root 15 is the adjacent side, 4 is the hypotenuse. So this is also square root 15 over 4, right? Okay, but yeah, draw those out. Next one here, they give us this kind of expression here, equation, with these different letters, and they just want us to solve it for 4j plus 9, right? You can kind of see that in the answer choices. This is a very common question. They give you things like this and you got to rearrange it. There is a way you can do it in Desmos. I'll show you that as well. But this is actually not too bad, to do algebraically, but I'll kind of show you like how you can do it in Desmos in case you don't feel comfortable doing it algebraically. First thing you'd want to do is multiply both sides by 4j plus 9. So it looks something like this. It'd be 4j plus 9 times p equals k, right? And now just to get the 4j plus 9 by itself, I'm just going to divide by p on both sides, right? So that's going to be k divided by p. That's our answer. But let me show you how you can do this in Desmos as well, because some of them are trickier, right? And if you kind of know this like hack in Desmos, it's kind of pretty cool and makes it easy. So if you just type this original equation into Desmos, it's not going to draw anything for you. And you want to understand why, right? Desmos, if it has an equation, Desmos, to show you a picture, it just wants x and y and nothing else, right? Numbers, right? So if you have like other variables, it's not going to draw anything for you. So here's a cool thing you can do. You can actually replace these things with like numbers, right? Or in variables. So I can make PBY, I can make KBX, and then for J, I'd have to pick a number, right? So if you're plugging in numbers, never use 0 or 1. Weird things tend to happen with that. So usually like if I have to pick a number, I pick like 2 to start, right? But you see now, like, this has a graph, right? And basically the question is just one of these has to be the same thing. So one of these has to be the same graph. So now you see, I can enter this one in. We know it's the correct answer already and make the same substitutions. I made J be 2, right? So it's going to be 4 times 2 plus 9 equals K, which is my X, over Y. And you see, it's literally right on top of the original one. So I know that's the correct one. That's the match. Whereas, for instance, you see if I put in B, answer choice B, with those same substitutions, it's going to be X times Y. This is what B would look like, right? So that's obviously not the same graph. So this is going to be a useful thing, especially if you don't feel comfortable doing like the algebra there. There's no reason you should get that wrong if you know this approach. Next one here, inequalities. This is something simple, something you see like pretty much every test. You can type in inequality, right? And what it'll do is it'll draw like the shaded part for you. And basically the solutions have to be in the shaded region, right? So the easiest way to do this is add a table and just, you know, plug in one at a time. So you see the first, if I try A, 3, 21, it cannot be on the line when it's a broken line, right? So right away, A is wrong. 321 doesn't work. So I go to B, 326. You see, now that's in the shaded region. So far that one's good. Next one, 5 and 42, right? That's outside. So B's not correct either, right? We can get rid of those two. Next one, 3, 16. Let me go back and do that. That's outside, so that's not it either. So it's got to be D, but I'll show you. I'll put them all in, and we'll see they're all in the shaded region. 326, 552, that's inside. And then last one is 8 and 91. Let's see, should be in there. Yeah, there it is, right? All three are kind of like in the shaded region, right? So those are pretty simple as well. Inequalities, just put in Desmos, make sure it's in the shaded region. Next one, line L is given by this equation. Line N is perpendicular to line L. What is the slope, right? So, okay, so it's about lines and it's about slopes, right? The only way you can see slope really if it's in slope-intercept form, right? So we want to first rearrange this equation so it looks like it's in slope-intercept form. Then we can see the slope, and then you just got to remember these two key phrases. Parallel is going to mean same slope. Perpendicular means opposite reciprocal, right? So you got to do a little bit of algebra here, right? But it's not too bad. You see, I'm just going to subtract 12x on both sides first, and then I'm going to divide by 3. So it'll be negative 4x plus 5/3. So my slope for this line is negative 4. Therefore, if I want perpendicular, it's the opposite reciprocal. It's 1/4. Next one here, we get an equation, and it says, in the given equation, D and G are positive constants, unique positive constants. That means they got to be different numbers. When the equation is graphed, how many distinct, that means again, different x-intercepts will it have, right? Well, if you put an equation into Desmos, you will see the graph, and then you can always kind of click on x-intercepts, right? The only thing you got to know here is it's not going to give you a picture right away because it doesn't know what D and G are, right? So what you can do is just like give it 2 different positive numbers for D and G, right? There it is. Here's my graph, and I can see that it has 3 distinct x-intercepts, right? So that's going to be 3, right? So here, yeah, I can just plug in numbers for D and G, right? So you might be wondering, like, when can I do that, right? So they'll tell you usually, like, it's almost always the first sentence, something is a constant, right? A constant, you know, here just means like it's a number. And I would say this is a good, like, you know, rule that you can kind of abide by, and it'll work probably like 90% of the time. You can plug in numbers for constants as long as the question's not, you know, what is that constant, obviously, right? So if the question was, what is D or what is G? I can't just plug in whatever I want for D or G. But here, that's not the question. So that's why we can do that. And, you know, then we'll get our graph, and then it's pretty simple, right? Next one here. For the exponential function f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k as a coefficient or base? Okay, this, I've seen different variations of this. Most people get this one wrong, so I think this is the hardest question of this whole module 1 so far, right? But it's actually pretty basic if you've seen this type of question before, right? The question itself is like what people I think don't understand. They're saying like, which of the following equations, so one of these, shows the value of k, so we're going to need to know what k is, right, as a constant, coefficient, or the base, right? So when you have an exponential function like this, right, the 50, that's the leading coefficient. The 1.6, that's the base coefficient. And this +1 up here in the exponent, that's just the constant, right? So the question's basically asking us to find k, and we can find k because you see it tells us how to find k. It's just the value of f of 1 is k. And then we just got to see, like, is it literally one of the numbers we see in any of these equations, right? So it's a pretty simple problem if you've kind of seen it before. It's kind of silly, actually. But you see, I'll type in a, and then I'll find f of 1. So f of 1 is 128. Now 128 is not any of these numbers in this equation, so it's not a, right? So then we go to b, right? B is 80 times 1.6 to the x. We get 128 again. 128 is not any of these numbers in the equation, so it's not b. Then we try c, right? C is 128, and then it would be 1.6 to the exponent x minus 1. Yeah, 128, and yeah, 128 is the leading coefficient here, so that's the one, right? I've seen other variations of this where it says like find the maximum value or find the y-intercept, and it's like, is the y-intercept one of the constants coefficients or the base of the equation? So you get different variations of that, so if you've seen it before, that's not too bad. Last one here, module 2, right? This one's pretty basic. We got a function, it's a quadratic function, just type that in. And this one has a transformation, right? It's not really important in this problem specifically that you understand this is a shift left 5 units, but you want to understand transformations, right? Because we'll see that other places, right? And sometimes we have to write them, right? So if you have your transformations, you just got to know about these translations and shifts. That's really all the test ever asks you about. I haven't really seen anything ask about stretches or compressions or even reflections really, right? But you want to understand how to write like a vertical shift or a horizontal shift, right? So here you see this is horizontal, it's x plus 5. That's how I know it's left 5, right? Here's my example here. X plus 4 means left 4, right? But like I said, here you don't really need that because they already wrote it for you, right? And so you can just type this in and you see, here's my transformed one, right? And the question is, for what value of x does it reach its minimum? So questions about minimum or maximum are always going to be about like usually quadratics because that's at the vertex. And here you can just kind of click on the minimum. We can see the x value is -13 and that's our answer, right? So that's it for module 1, right? That's not too bad. Quick break before module 2. I want to show you something that I built that's directly relevant to what you're watching right now. The way you actually get good at SAT math is reps. When you've done 50 of a question type, the 51st one isn't a question anymore. It's just automatic. That's what Sigma Prep is. Practice problems organized by topic and difficulty, a video explanation on every single one, instant feedback so you don't keep making the same mistakes. But here's the new part. This exact test, the one I'm speedrunning right now, is on Sigma Prep as a full practice test, mock test 8. Same 2-module adaptive format as the Bluebook, same topic mix, same difficulty curve. But every problem is a fresh and slightly different variation of the ones you're watching right now in this video. So your score will actually mean something. So when you're done with this video, go to sigmaprep.io and take this version of the test yourself. See if you recall the strategies I'm using here. If you do, you should walk out with an 800, just like I'm about to. And if not, it just means you need a little bit more practice. When you finish, you get your score and a full breakdown. Every question you missed has a video explanation where I walk through exactly how I'd solve it. And then, this is the best part, the part that actually moves your score. One click builds you a practice set from exactly what you got wrong. You don't have to wonder what to study next. The test tells you. So you can start for free. Your first mock test is free, and so is the diagnostic quiz if you want a 15-minute picture of your weak spots first. If you grind this, there's no version of you that doesn't improve. sigmaprep.io, link in the description. Now back to module 2. Okay, module 2 here. Open up Desmos. 4x plus 6 equals 18. Which of the following equations has the same solution? So this is basically simple. You can see they just isolated 4x. So if you just subtract 6, it'll be 12. But let me show you what else you can do. Because it's, again, talking about solution. We talked about that in module 1. You type it in, you can see the solution, right? Now, one of these has to give us the same solution. So you see, if I type in B, for instance, that's not the same solution. I type in C, is the same solution, right? So if it was something more complicated, that's how you could do it, but that's pretty basic. Next one, function. It says the total cost f of x to lease a car for 36 months is given by this equation, where x is the monthly payment. What is the total cost to lease a car when the monthly payment is 400? So functions are really simple, right? Because a function just has two variables like x and y, right? They're always going to tell you what the variables are, so that's an important part of like reading it, right? I know f of x is the cost. I know x is the monthly payment, right? They got to give you one so you can find the other. In this case, what do they tell us? They tell us just that, you know, x, the monthly payment is 400. So you see, we just kind of plug that in for x and we get our answer. Next one, if the graph of this equation is shifted down 5 units, what is the y-intercept, right? There's a couple ways you could do this, but this kind of circles back to what we were just talking about at the end of module 2 with transformations, right? You want to be able to kind of write a shift sometimes, right? So you see, sometimes people will make a mistake here. They'll just kind of like put -5 at the end of the equation. That doesn't work unless you have kind of y isolated, right? So you see, I kind of put in this original one, and then over here, if you wanted to properly kind of shift this in an easy way, right, you'd want to isolate y. Now, it's not the only way you could kind of do it, right, but it's probably like the way you can do it and not make a mistake. So here you see, if I just kind of take this whole equation and then divide it by 33, right, it's still the same line, right? These are all the same line. You see, like that's the same as the original one. Now you see I can do, let me keep the original one. Now I can put -5 at the end of it, and it literally shifted it down 5 units, right? And then I can just kind of click on it and see it's 4, right? Now that wasn't the only way, because like it's about the y-intercept, so you could have just found the y-intercept of the original one, and that's just literally going to move down, 5 units, right? So you don't really have to do that, but in another problem, it might be like if it was about x-intercepts, right? You see, like if they ask you about the x-intercept, then it's not really going to be like we move this down 5 units or something. It actually moves this way, right? And it's not like proportional. So that may be why you kind of want to understand that and how to apply transformations correctly, right? Next one, they give us a linear function, right? Like I said, you want to be able to recognize some of these equations. This is a line. They want to know what's the y-intercept. That's the -2 there, right? But again, even if you don't know that, right, just type it into Desmos. Whenever you have an equation, right, type it into Desmos and you can literally click on intercepts, right? So no reason to get that wrong either. Next one here, give us a graph with this equation. And the equation basically tells us, it shows the relationship between shares of company A, X, and the number of shares of company B, Y. And it says which equation represents this. These are silly. You can literally just type this in and see if it's the same graph, right? Obviously, it's not A, right? This graph goes up. So then I try B, right? And it looks like this. So this potentially could be it, right? It looks like it goes down. Just check, like, does it have the correct intercepts, right? The y-intercept 40, the x-intercept is 60. That's it, right? That's the simplest way to do that. Just literally put it in and see if it looks the same. Systems of equations. This is our first system, right? Usually they have multiple systems in a test, right? Simple, freebies, right? Just throw this in the Desmos and you can see where they intersect. Just make sure you're zoomed in correctly to find where they intersect. Here it is, right? So this is our point. So we just got to do x is 2, y is 3. So it's going to be 17 over 2 times the x, which was 2, plus 18 times 3. And we get our answer 71. Simple. Systems should be freebies. Next one. Function gives us a function. And here we go. A transformation again, right? So this just shifted down 3 units. A lot of times, again, they just write it for you, right, with the transformed notation. But, if they don't, you got to know how to kind of write that yourself, right? So that's why we talked about that. So here it is. Let me just zoom out. Here's my graph, right? And then I can literally just write f of x minus 3, right? And you can see the second graph is just moved down, right? So down 3 units. So they want to know which table represents this transformed one, right? So I don't want to look at the original one. I can turn that off. I want to see this one, right? One easy way, there's a bunch of easy ways you could do this, honestly. But you see, I can just put in a table and I can put in answer choice A, and right away I see that point is not on this transformed one, right? So that's not it. So I can do -6, -3, that's on there. I can do -5, -3, that's on there. And then I can do -4, -3, that's not on, or, well, it wasn't -4, it was 4, 3. There we go. So all 3 points, for answer choice B are on the transformed one, so that's correct, right? Next one, the function Q decreases by 45% for every increase of x by 1. We talked about this in module 1 as well, right? Like I said, these are fundamental things. It's an exponential equation. You can see that in the answer choices. If your equation has a variable as an exponent, it's an exponential equation, right? Decrease of 45%, right? That's going to be this number in here, right? We got to do 1 minus 0.45, right? Or if you're not comfortable writing, percents as decimals, just take whatever percent it is, write it over 100. That'll be the same thing. 0.55 is what we want to see in here in the parentheses, right? And this is the only one that has that. So that's it. This other piece of information was telling you, remember we said for exponential equations, this value in front is your y-intercept, right? When it's in this form where the exponent is just x, right? That's what this is telling us, right? This is telling you y-intercept is 14. Remember, y-intercept is when x is 0. So that's how you know that. But again, just knowing that decreased by 45%, it had to be just C, right? But that would be those two together. Next one, submersible device is used for ocean research. The function g of x is this equation, right? So you can type that in just so you can see what this function looks like, right? But this is a quadratic. So here we go, x plus 19, x minus 35. Here's my quadratic, right? So what do you need to know about quadratics, right? Basically this, right? Common questions about quadratics, right? They'll give you this quadratic and then they'll ask you like in terms of context, right? And there's some keywords you want to know. If they talk about like an initial amount, initial height or whatever, that's the y-intercept. If they talk about like when something hits the ground or whatever, that's the x-intercept. And if they talk about the max or min, you want the vertex, right? So this question says, how many minutes after collecting the sample did it take for the submersible device to reach the surface, right? So reach the surface in this case is going to be, it goes underwater and then it's going to come back to the surface. So it's another way of just saying like when it hits the ground. So that's basically it. You want to be able to read that question and be like, oh, this is a hits the ground question, right? So they want the x-intercept and then that's just 35, right? No math. You don't need to do anything. You just got to make those connections. So remember those three common, quadratic questions that they'll ask, right? Next one. Cube has an edge length of 68 inches. A solid sphere with a radius of 34 inches is inside the cube such that the sphere touches the center, right? So here's like where, this reference sheet is useful with volumes, right? That's basically the most useful thing. They'll tell you, here's the rectangular prism, your cylinder, your sphere, your cone, everything, right? So if you don't know those volume ones, that's all right. It's usually one of these. So that's when that reference sheet is actually useful, right? So we got a cube and inside the cube is a sphere. So they don't exactly give you a cube, right? But a cube is basically this. It's a rectangular prism, but a cube just implies, and I have a picture here for that, right? So let's talk about that a bit. They'll give you this rectangular prism, but then they could talk about a square prism or they could talk about a cube. It's really the same thing. It's just a rectangular prism implies that length, width, and height are different, dimensions. Square prism will imply that the base are the same, but it's a different height. And then a cube is just all of them are the same, right? So cube is like the simplest one. So here, it would just be 68 cubed to find the volume of the cube. And then we got to take away the sphere, right? So 4/3 pi, and then it's r cubed for the sphere. So it's 34 cubed, right? So we could just kind of type that in like that. Here's our number. That matches A. We're done. Next one, what's the sum of the solutions? We've seen this a few times, right? That's what I say. You got to remember that key word. It's a beautiful word, right? You don't need to do any algebra here, right? Type it in exactly how you see it. You do not have to waste time simplifying it or doing anything, right? So just type it in exactly how you see it and you'll see your solutions, right? Here are my two solutions. They want the sum, so I'm just going to add those two numbers together. That's going to be 9.6 repeating. So you don't want to round these. Just enter in as many numbers as you can and that'll be acceptable, right? So the test tells you, by the way, if over here, if you ever not sure like how to enter something on every fill-in question, they'll tell you over here, explain how to answer it and how not to answer it, right? So like this one, I wouldn't want to, you see, like cut off any of these sixes, just type in as many as you can see, right? Okay, next one, inequalities. We literally saw this in module 1, right? So just type this in. It's basically the same exact question, basically, right? Put in your table, and again, just make sure they're in the shaded region right away. This one's on the line. Remember, what's broken line, that cannot be on the line. So not A. I can try, you see, for B, 316, that's inside. Try the next one, 536. That's outside, so it's not B. Next one, 316, but it's 528. Let's check that out. That's inside. And then 7 and 40, right? That's inside. So C is the one we need here, right? Next one, what's the diameter of this circle equation? So we talked about the circle equations as well, right? So if you know this, you know that this value, 16 over here, is r squared, right? Therefore, r is just 4. So if you know r is 4, the diameter is 8, right? But here's the great news about, these circle equations. Even if you don't know that or forgot it on the test, right? Or just want to make sure, right? You just type in a circle equation and it'll draw a circle. What you want to know is you can always click on the top and the bottom of the circle, right? You see, I can't click on the side. Sometimes it'll look like you can click on the, once the horizontal endpoints, but that's not the case. Sometimes it might look like it, but it might be the intercepts or something, right? You want to know you can always just click on the top and bottom. And so you see this distance from -1 to 7 is 8 units. That's our diameter. So yeah, 8 units, right? So that's another way you could do that. But if you know that circle equation, that's great. Next one, 14. Quadratic equation, right? And we don't know what C is, and they're telling us it has one solution. This is a discriminant question, right? This is something pretty much most tests will have here towards the end of module 2, right? You want to know this, and you want to kind of know like your discriminant. Here it is. Here's our picture, right? The discriminant is the part of the quadratic formula that's inside the square root, right? And the SAT loves this question, right? You got to know these 3 cases, like what the discriminant has to be for 2 solutions, 1 solution, or no solution. And then you just kind of take your A, B, C value, type one of these into Desmos, and you get your answer. It's really easy. This one's already in the form we need it to be. It's already in like the standard form of a quadratic equation, right? Sometimes it's not, and so sometimes that's the annoying part. You got to do a little bit of algebra to like write the equation in its standard form so you can see the A, B, C. Here we don't have to do that. We see A is -9. I'll write these here. A is -9. B is just 30, and then C is C, right? So I'm going to type in my discriminant. It was 30 squared minus 4 times the A, which is -9, times the C. And it said it has one solution, right? So where'd my discriminant go? There it is. It moved. Okay. One solution is it equals 0, right? So then it's just like literally equal it to 0. And that's it, right? And you see when I type it in, I put the parentheses around B, A, and C. That's very important, especially for B, because if B was negative and you don't have the parentheses around, it's not going to square the negative along with it. You'll get it wrong. So just make sure you have parentheses around B, A, and C. Finally, remember, Desmos won't solve it when the unknown's not X. So just change like whatever that is, whatever your unknown is, to X, and we get it. Is -25. Now, you could have done this without knowing the discriminant, because you could have, it's multiple choice. You could literally just try these in for C, right? Like, let me show you that. If I type in -9x squared plus 30x plus C equals 0, right? I can then just try, right? Like if I tell it C is 3, see, there's 2 solutions. If I tell it C is 0, there's 2 solutions. If I tell it C is -25, I see 1 solution, right? So you could have done that this way, but I went over to the discriminant because most of the time this question is not multiple choice for that reason, right? If it was multiple choice, you could do this every time. Normally this is going to be a free response one, so you want to know how to type that discriminant in so you can solve it. Okay, next one. Triangle XYZ is angle Y is a right angle, and angle Z is 33. Okay, another triangle one, right? We're going to go back and sketch it, right? Like I said, that's going to be your geometry. So they said Y was the right angle. That's the only thing that matters. Okay, let's kind of get rid of these. And they said angle Z was 33 degrees. So let me kind of type that in over here, 33. That's our triangle so far. Okay, what else is going on? It says the length of YZ is 26. All right, so let's go back and put that in. So YZ is 26. That would be over here. And 26, not 25. And then it says the area can be represented as this, K times tan 33 degrees, right? Okay, so when you have a right triangle, the area is just, the product of the legs times a half, right? Area is 1/2 times base times height. You need your base and height to be perpendicular, so those are the legs when we're talking about a right triangle, right? So if I have areas 1/2 times base times height, right, I can start kind of filling this in. They said, we know B is just B, but height is 26, right? And what do they say about the area? They said the area can be represented as K times tan 33, right? So there's a little bit of trig here as well. We want to solve for K, right? So if you want to solve for K, you got to know what B is, right? K's got to be the only unknown. So here, you got to represent B somehow. And this is honestly a hard problem, right? Because you got to understand SOHCAHTOA to do this, right? If I wanted to write B, and I have this angle 33, right? What ratio should I use? Well, opposite of 33 is B, so we want the opposite. And we have the adjacent, right? So I can write something like this. Tan 33 is equal to B over 26. So then to represent B is just 26 times tan 33, right? So now I can take this and I can kind of plug it in over here. So let's go ahead and do that. So this would look like this. It'd be 1/2 times the B, which is this now, 26 tan 33, right? So this is basically our equation, right? And they want to know what is K, right? So if you take a look at this, right, you can just put this in Desmos and divide by tan 33. But if you divide it by tan 33, it would just kind of cancel out tan 33 on both sides, right? So what that would look like then would just be this, right? We'd have K equals 1/2 times 26 times 26. That's going to be our final answer. So that's kind of a tricky one though, right? So you can kind of expect that. Probably not like something you'll see very often. But yeah, that's module 2, right? Sometimes it has like some weirder things, trickier things, right? That's one of them. Next one here. This is a much more common thing, right? You got things with percents, right? We saw this in module 1 where it was a basic one. We just translated into an equation, got our answer. This multi-step, right? They tell you regular price of a shirt is $11.70, right? So read this one sentence at a time and put your equations together, right? Regular price, I know regular price. Second sentence here, you see just the first part of the second sentence is an equation. It says sale price is 80% less than regular price, right? So I can write this. Sale price is 80%, so 1 minus 80 over 100, right, for 80% less than the regular, right? And what do I know? I know regular, right? So I can figure out sale price, right? It would just be this. It'd be 1 minus the 80 over 100, right, times 1170. This is my sale price now, right? So I know sale price is 2.34. Then I keep reading, right? Then it says, you see, this is another equation. Sale price is 30% greater than the store cost. And that's the final question. What's the store cost? So you see one more equation. It's sale price is equals 30% greater. So 1 plus 30 over 100 and times the cost, right? So you see, if I want to figure out cost, what do I have to do to figure out cost? Cost is going to be just sale price divided by, that quantity, 1 plus the 30%, right? 30% greater. And I know, again, what sale price is. We already figured that out, right? So 2.34 divided by that quantity, 1.8, right? If you don't write that out, chances are you're going to get that wrong, right? So you want to feel comfortable writing these percent equations. This is something pretty much every test has, right? And if you can do that consistently, then these really aren't that bad. What people tend to do wrong or where they get in trouble is percents are weird, right? Like here it says sale price is 30% greater than the cost. So a lot of people mistakenly think that if they do the opposite, if they do 30% less, then it'll be the same thing. And that just doesn't work with percents, right? That's like a common thought in math. If we do the opposite, we'll kind of get the other result, but it doesn't work with percents. So don't do that. Next one here, triangles A, B, C, D, E, F, B and E have a measure of 27 degrees, C and F have a measure of 41 degrees. Which additional pieces needed to determine whether they're congruent? Okay, so yeah, let's sketch this out, right? Again, geometry is where we sketch this out. Let me just borrow this triangle here. The thing is, we don't know that this is a right triangle, so I kind of get rid of that. So we have A, B, and then C. And let me get rid of this angle as well. And then we also have DEF, right? That's kind of what they told us. So DEF. And what else did they tell us? They told us that B and D are 27 and C and F are 41. Okay. So B and E are 27 and C and F are 41, right? So let's go ahead and put those in. And that's what we have. Okay. So for congruency, right? I don't have a picture for congruency right now, but you got to remember for congruency, you can prove it using side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg, right? Those are our congruency theorems, right? So you obviously have two angles here. That's what they gave us. So we're going to definitely work with either angle, side, angle, or angle, angle, side, right? So we need a side, right? You either need this side, the pair that's kind of between them, right? Or it could be like this other pair, right? But we need a pair. Because if you have AC and DF, that's angle, angle, side. Or if you have AB and DE, that's angle, angle, side. Or if we have, BC and EF, that's angle, side, angle. So we just need to know like that one of these pairs of sides, right, are basically the same, right? And so, yeah, just knowing angle A is not enough, right? Because it's got to be about the sides. Just knowing AB wouldn't be enough because you need to know the other side. So here it is, the sides of BC and EF, right? We can see those are the ones that correspond to each other. If you knew these sides, right, you'd be able to tell whether they're congruent because of angle, side, angle or not, right? So that's it. That's the one. The other one, this one's an interesting one. If it was similarity, the answer would be D, right? So let me kind of like mention that since we're here as well, because sometimes it will be about similarity, right? Similarity, there's a few ways to prove it. You could actually show just angle, angle, side, 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 or side, angle, side. Now with the sides have to be proportional in similarity. That's the only difference. But you see, one of the ways to prove similarity is just angle, angle. And we have two pairs of angles. Therefore, if this question was not congruent, if it was similarity, which you might see, then it would be answer choice D, right? But it's not in this case. But just a heads up. This one here, very common question, right? they give you two lines, right? You can type in the first one, it'll draw it, right? Because it has everything in that equation. And then this other one, if you type this in, it won't draw it because it doesn't know what R is, right? This one, it's a very common question. They give you a system and they tell you it has no solution, right? So with our lines, remember, no solution just means that they're parallel lines, right? So that's how you can solve it algebraically. You basically know they have to be parallel, which means they have to have the same slope. So I'll show you that, but here's another cool thing you can do, right? You can add this slider here, right? You see, you'll set the value to RB1, and you can just slide it around until you find like what value would make it parallel, right? So by default, this slider is just set from 10 to -10, and you see here, there's no number between -10 and 10 that's gonna make it parallel. You can adjust this. If you click on one of these endpoints of the slider, I can make it like, let's say, -40 to 40. And I like to make the step be 1 because then when you move the slider, it moves it up and down by 1, right? And this answer is usually an integer. So you kind of keep sliding it, and you see they're looking more and more parallel. And if you zoom in here at -34, that's exactly when they're parallel, right? So that's going to be our answer. So that's one way to solve it, but here's the other way to solve it, right? Maybe a little bit better way. Most of the time, that'll be a nice number, so I think the slider works well, but like the best way algebraically is just to know, again, no solutions means that they're going to be parallel. It means they got to have the same slope. So to see their slopes again, they got to be in slope-intercept form, so just kind of rearrange this equation. So you see like this first one, I'll move 48x to the other side, I'll subtract 30y, so it'll be -102y equals -48 plus 24. And then I just got to divide by -102, right? So this will be 48x over 102, the negatives cancel out, plus 24 over -102. I don't really have to simplify it because Desmos will do the math, but this is my slope for this one, right? And this other one, I just got to divide by r, so that'll be 1 over 6r minus 16 over rx, right? So now you see I have the slope of this one, it's 48 over 102. It has to equal the slope of this one, which is -16 over r, right? And you see, Desmos can solve this if I just change r to be x, right? So if I just change r to be x and I zoom out, here's my answer. I can't click on it because x is in the denominator, right? But if you see, if I zoom in on it, I see it's that value of -34 that we already found. So two ways you can do that, right? Next one here. It says the factor is x plus 2b, right? B is a positive integer. Oh, this is, this is kind of like a tricky one, right? So what you kind of want to know here is they tell you one factor, you can figure out the other factor, right? The only thing that matters when you're like foiling is first times first. So I know the other factor has to be 3x for the first term because all of these are 3x squared. And then it has to be plus 7 because last times last has to give us 14b, right? So this is it. And if you were to kind of FOIL this out and expand it, you would get this. You would get it'd be plus 7x, right? And then it would be plus 6bx and then plus 14b, right? So we want to know like which one, the only thing that's different in these answer choices is the middle term, right? We want to see like if I do 7 plus 6b, because that would be the middle term, right? Which one of these could be like this middle term, right? And they tell you that b is a positive integer. So you can just try it. You could be like, oh, b is 1. If b is 1, it should be 13x. That's not one of them. If b is 2, 19. If b is 3, 25. Keep going. 31 for 4. 37, so that's not it. 6, 43, that's not it. B is 7. 49, right? So that's the one that kind of like works, right? So I've seen this problem before. It's a pretty annoying problem. If you haven't seen it before, you might not get it right? That's why like practice and repetition is the key here, right? You've seen things before. There's a lot better chance that like when you see it on the test, you'll kind of recognize it, right? Next one, perimeter of an equilateral triangle is 624. The height is k square root 3, where k is a constant. What is the value of k? So another geometry one. So this one had like a lot of geometry that we kind of have to like sketch out, right? So let me just kind of take one of these away and let's just change it a little bit because it says it's equilateral, right? So maybe it looks more like this. So if it's equilateral, that means like all the sides are the same. And what they told us was they told us what the perimeter was, right? The perimeter is 624. So we're going to divide that by 3. So we know that each side is 208, right? So it's going to be 208 all the way around. So 208, 208, 208. The other thing you want to kind of know about, you know, obviously an equilateral is like all the angles are going to be 60, right? So 60, 60, 60, right? Okay, so they want to know the height, right? So what happens when we draw a height? It just kind of splits it in half, right? So Now we do kind of have like our right triangle. So let me go ahead and borrow this right triangle again. So I don't have to draw it. Okay, so we got our right triangle. So now this angle is going to be 30, right, instead. And also this bottom one here, right, because we cut it in half when we do this, it's going to be 208, it's going to be, and then it's going to be 104 down here. And they want to know the height, right? So an easy way to kind of figure this out is if you know your special right triangles, right, which is something that they do give you here in the blue book, right? In the reference sheet, we kind of have our special right triangles right here. We want to just find the 60 side. The 60 side is x root 3 and the 30 side is x, right? So over here, this side just has to be, 104 square root 3, right? And that's the question. It said it was going to be k square root 3, so it's just 104 in that case, right? That's our answer. If you didn't know that, you could just kind of also at that point, right, when we draw this, it is a right triangle, right? So just do Pythagorean theorem. So I'll show you that as well. You see, I can just type in k, or x I'll use because we can't use k as like our variable. K square root 3 squared plus 104 squared equals 208 squared. Zoom out, right, and we'll see our answer is 104. So one of those two ways is how you can kind of solve that. Next one over here, this data set. It's a histogram, right? What you got to know about histograms is we don't actually know the numbers, right? Like here, you just know that there's 3 numbers between 20 and 30. Over here, we know that there's 3 numbers between 10 and 20, right? So they want to know what's the smallest possible difference between the means here, right? So you got to kind of think about this question. It's a weird question. If you want the difference between the means to be as small as possible, it means that the numbers should be as close to each other as possible, right? Because if the numbers are close to each other as possible, their means will be as close to each other as possible, right? So you got to think about like what these numbers could be. So again, like in A here, the first 3 numbers have to be between 20 and 30. And it says it can be 20, but less than 30, and they got to be integers, right? But over here, the first 3 numbers have to be between 10 and 20, right? Again, can be 10, but less than 20. If you want these to be closest to each other, you'd want them to be like as close to 20 as possible for the first 3 numbers, right? So for A here, I would pick the numbers to literally just be 20 because they can be 20. But in B, they can't be 20, right? Because it describes it here. It says greater than or equal to 10, but less than 20. So for B, it would look like this. You could pick 19. That would be the greatest integer you could have. And then you see, you can just kind of continue this pattern. The next 4 numbers here have to be between 30 and 40. The next one's between 20 and 30, right? So you'd pick like 30, 30, 30, 30. And then over here, you'd pick 29, 29, 29, 29. And you could continue this, right? You can do this for like the rest of the numbers, but it's not very necessary. Once you kind of understand it, you can see you could always pick numbers in A that are just 1 bigger than the number in B. So if you want to find the mean, it's just going to be a difference of 1. But you can actually kind of calculate mean as well, right? And you see here, if I do the mean between these two, the difference is 1 without writing all the numbers, right? So that's more of a conceptual question. Last one here, we got like these results, and it says the table shows the results. 803 voters were asked which candidate they did vote for. According to polls, 6,424 people voted in the elections. By how many votes would Angel Cruz be expected to win? Okay. So this is statistics and statistical inference, right? So basically, you want to extrapolate these poll results into the actual results, right? So you can set up like from our sample to like the total and what we kind of expect, right? So if you want to do Angel Cruz first, Angel Cruz had 483 out of the 803 votes, right? And we want to know how much would that be out of the total, right? And so this would be what Angel Cruz would get, right? So this is Angel Cruz. A lot of people pick this answer, but that's not what the question's asking. It's not asking how many votes Angel Cruz would get. It's asking by how many votes would Angel Cruz win. So you want to basically take the same thing, but then also figure out Terry Smith, right? And you can kind of have both of them, and then we want to like subtract them, right? So it's these 2 numbers, you subtract them, and we get 1304. The other way you could do it that's a lot quicker is just take the difference between those 2, right? Like this. And yeah, put that in there, and you can take the difference and extrapolate the difference to the total. This is the difference in their total votes, right? So a couple ways you could do that. So that wraps up module 2. A lot of geometry, so a lot more sketching here. Sometimes that's a little bit more, time consuming than it would be otherwise, right? But I think Other than that factor question and maybe that trig one with the area, K times tan 33, these are all regular things you'll see, right? So just make sure you do your kind of practice. That's what Sigma Prep is built for. Go over there, practice. You should be able to recognize all of these and go through that a lot faster, right? And there should be no surprises. So that's the idea, right? Just get your reps in, do the practice tests, take advantage of that, and yeah, let me know how it turns out. You know, this should be a test that's fairly predictable most times. Let's check the score for this. And there it is, perfect 800. If you watch this whole thing, you clearly care about your score and want to improve it. So here's your move. Go to sigmaprep.io, take this exact test, our mock test, and see how close you get. Whatever you miss, it will build a custom practice set for you afterwards. That's the whole game. Reps and feedback. Like and subscribe. Next test coming soon.